Hey guys, welcome to the Code to Coffee. And today we are going to learn the subarray sort. Okay, so let's start. The problem statement is given an array of size at least 2, find the smallest subarray that need to be sorted in place so that the entire input array becomes sorted. Okay, so this array is given. So let me write this array here. That is 1, 2, 3, 4, 5, 8. Then 6, 7, then 9, 10, and 11, right? And what we need to find out? We need to find out the subarray which need to be sorted in place. Okay, so we closely observe this subarray. Okay, this array. So this is in the sorted order. So 1, 2, 3, 4, 5. Then it should come 6 here, right? Okay, then if you go here, then 8, 6, 7. So till here, if you find after this, it's sorted, and before this, it's sorted, right? But this subarray is not sorted. So that is what we need to find, right? So basically, we need to give the index. So what index need to be sorted? So if we index this one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And in this case the result should be like 5 and 7 because these indexes need to be sorted. And what we can do, okay, so let's start with the brute force approach. So what we can do, we can sort this array, right? Let me sort. So if we sort this array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is the new sorted array. Okay, so this is the new sorted array. And what we can do, we can compare with the original whether this index is correct or not, right? So at the 0th index 1 is 1, right? It's a correct, right? Similarly we can compare, and once we reached here, right, we can just check if this index is have the same element or not. So if you see, the element is the differences, right? The element differences. Similarly, the last from here we can also check, right? So from the left side and from the right side. Similarly, we can check from the right side whether the element are same or not, right? So till here we are fine, but here we can say, okay, here we need to we are getting the differences of element, right? So that will give us the sorted array, I mean sorted subarray index that need to be sorted, right? But the problem is here, first thing we need to create the new sorted array, right? So that will be like space complexity will become the order of n, right? And because we need to sort, right? So in that case, if we'll go with the sorting algorithm, the best case, I mean the best sorting algorithm will give the in order of n log n. So these two are problematic, right? Because first we need to create the extra space, and also this time complexity is also high, right? What else we can do? Is there any way so that we can calculate this subarray um, efficiently? Okay, let's see this one. Okay, so if you closely observe, if this is the sorted array, if everything is sorted array, in that case, it should be like increasing or decreasing, right? So if this is 1, okay, the next one should be more than 1. The next one should be more than 2. The next one should be more than 3. And the next one should be more than 4. Like similarly, should be either increasing or decreasing. For now, what we can say, okay, it's increasing, increasing, okay. In that case, it should be always increasing order. So when we'll find, okay, so this element is not, in order, because after this 8, there should be some greater value, right? It should be greater than 8, but here we are not getting, right? Similarly, if we'll try to see from here, so from the right side, right? So the previous one should be less than the previous one, right? So I minus 1, this is I minus 1 should be less than I minus 1 should be less than I, right? And till this point, it's fine. But when we reached here, we could say, okay, now the I and I minus 1, right? I minus 1 is not less than, right? I should be greater than I minus 1. But here, um, okay, here I think, okay, no. At this point, if you see I minus 1, which is nothing but the 8, is less than I, no, right? We are not holding this, right? At this position. So for the 8 and for the 6, okay, for the 8, I should be greater than, you know, should be greater than I minus I plus 1, right? I should be, okay, sorry, I should be less than I plus 1, right? So this condition is not fulfilling at this point, and this condition is not fulfilling at this point. So that's mean these two element is not in the correct position, right? Once we finalize what are these, element which is not in our correct position. So what we found, okay, 8 and 6 is not in our correct position. We need to find where we need to place this element, right? So let me write again this array, okay, 8, 6, 7, 9, 10, 11, right? And what we can say, which is the least one, right? This is the least one, nothing but the smallest one, and this is the largest one. So we can just check. The smallest one should be somewhere left side, right? From left side. So what we can check, let's say we'll start I equal to from here. So the array of I should be, because we are going in this direction, right? In this direction. So what we can check, if can we place the smallest one here, right? Can we place the smallest here or not? This is we need to check. And how we can check? We can check I, if I, array of I is less than smallest one, right? So if this element is less than this element, smallest, that's mean this is at the correct position. Now next we can go here. So every time we reached here, we will find, okay, array of I is less than smallest one, right? But once we reached here, now I equal to nothing but 5. So array of 5 is less than 6 or not, and which is incorrect, right? I mean, this is not. That's mean our 6 should be placed at the 6. So we can just hold this one I value, okay? So instead of saying I, we can say left, right? So nothing but left. So the left value we found where we need to place the 6. Now the 8, which is the largest value, and how we can check what is the correct position. So we can start from the right side and we can say index is right, right? So what will be the our condition? So we can just check array of right should be greater than the largest one, right? So largest is nothing but 8. So all elements should be greater than 8. So whether this is the 11 is greater than 8, yes. 10 is greater than 8, yes. 9 is greater than 8, yes. But here, if you'll see, when the index is the right index is here, then the array of what is the index pointer is the 7, right? The index array of 7 is greater than 8. No, not, right? So we can just uh, you know have this right index, which is nothing but 7. Now we found two indexes, with left index and the right index, right? Left and the right is nothing but 5 and 7. So these indexes are the subarray which need to be sorted. So this is other way we can find the subarray, right? Now one more thing, let's say the function should return -1 in case of all the element are sorted, right? How we can check? So if the all element are sorted, so this right will start from here and it will go till here, right? Till here. So in that case, right will become 0, right? And similarly, left will start from 0 and it will go till here. So now left will become 11, right? Because, and now what we can just check, we can just simply check if left minus right is greater than or equal to length of array, right? In that case we can just return -1, right? Okay, so this is how we can calculate for this edge case. So when this array is already sorted. Okay, so we are going to code this approach, right? This approach, because every time our two things we are calculating. First thing, to find this largest and the smallest element, which we can do with the for loop, which will be start from 0 to n-1, right? And here we can how we can find the smallest and the largest. You can just simply check if array of I is less than array of I plus 1, right? And array of I, I'm talking about this one, right? Array of I is greater than array of I minus 1. If that is the case, we can say that, okay, smallest, largest equal to array of I, and the smallest is also, really, it's nothing but the mean of smallest and AI. So this should be also because it's the largest, right? We can just check max of array of I and the largest. So this logic to get the largest and smallest, and the another logic is this one. Okay, from the left side we can just have a for loop which will be start left uh, equal to 0 till n-1, and what we can check array of I less than smallest Okay, and here we are saying left plus plus, right? Left plus plus. So what we can do here, we can define before the for loop left equal to 0. So once we are out of this for loop, we will get the left value, right? Because it's increasing. Similarly, you can have this another for loop for the right. So what you can say, the right will start from the n minus 1, right? And you can just say it should be, and right should be greater than or equal to 0, and right plus actually minus minus, right? This we can do. So let's code this approach. First we'll code this one, then code these two. Okay, one more thing, largest we need to initialize. We can say largest is nothing but the max value of integer. Okay, and the smallest, sorry, smallest should be max value, and largest should be min of integer, right? So let's code this one. So we have this function, main function, where we have defined this array, and we need to create one function subarray sort, right? Where we calculate the subarray, right? So let me just create the function subarray sort, which will have the array of integer. Okay, and what we can do, left is equal to 0, and right right to length of array minus, and we just need to check if what did we check here, right, left minus right. If left minus right is greater than and equal to 0, right, in the, greater than and equal to length of array, in that case you can just return or maybe print fmt dot println, let's just say already sorted, and with nothing but the minus minus, and you can return. But what if we will get something? Then we can say that sub array sorted, sub array sorted, but left and right, right? You can just say left and right. Let me just run with our left and right. So yeah, for now it's like we're getting, because we don't have the logic. Now let's write the logic in between. Okay, so we'll start with the largest and the smallest definition. So the largest is nothing but the math of uh, mean, right? Mean integer 16 or 32, whatever we can take, and the smallest is nothing but the math of max 16, max 16. Okay, you can have for loop, like this for I equal to 0, I equal to 0, I is less than, because it's the n, right? So we can do, okay, length of um, array, right? And I Here we can check if this condition, if array of I is less than I plus 1. If array of I less than I is less than I plus 1, array of I plus 1, and array of I is greater than array of I minus 1, right? Let me just write in the parenthesis. Okay, so sorry, because we are also doing the array of I plus 1, to just avoid the out of index, what we can just check, um, I should be less than length of array, right? Because if I is less than array, then I plus 1 is the correct, right? Array of I length minus 1, right? You can do like this. Similarly here, because we are going with the I minus 1, so what we can take here, I should be greater than 0, right? And here you can just largest should be nothing but the, let me, slice of largest, right? So you can have the max, and this is not integer. Okay, so here is a small correction. Okay, so this condition, okay, here we are checking the out of in order, right? So what basically we are checking the array of I, because the I is getting increased, right? So array of I is less than I plus 1. In that case, it will be out of index, out of order, right? So array of I is greater than I plus 1. Then we can say, okay, array of I is out of order. Similarly, when we are going from the right side, the array of I should be less than, array of I should be less, less than array of I minus 1. Then that array of I is out of, that is out of in order, right? So here you can just say array of I is less than array of I minus 1. So this is how we coded here. Array of I is less than array of I minus 1, and array of I is greater than I plus 1. Array of I is greater than I plus 1, right? And here you can say, okay, the largest and max of the largest and array of I, right? Now, similarly, we can calculate the smallest one, and here we can say the smallest an array of I, but here it's a mean, right? For now, also we can just print fmt dot print what is the smallest and the largest, right? For now, just to check purpose. Okay. Now, what we need to do next? So we need to find where we can place this largest and smallest, right? So this logic we are going to uh, code. Okay. So what we can do, let's write the for loop where left we already defined, right? Here left we already defined, but we can just check if left, because left we need to increase, right? Left we need to increase. So if left we are increasing, so that should be always less than the length of array, right? It should not cross the, the array size. And also we can check this condition, array of I is less than smallest, right? So array of I less than or equal to smallest. right? And then left plus plus. That's all, right? And you can have similar one more for loop, but here we'll check the right one, right? Right, because we are decreasing the right one, right? So we can check the right should be greater than 0. Okay, in that case, you can just check it should be greater than or equal to the largest. Then right minus minus. This is what we did. We basically coded this things, right? So the right should be array of right should be greater than largest. Array of right should be greater than largest. Here it should be left. Yes. So because once we are not, satisfying this condition, but we'll have the right position, right? Similarly, we'll have the left position. So that's all I think we calculated. Let's run this, and here we can just print this one. Let's run it. So okay, here we are getting some problem is here. Okay, so the problem was we should have the or, not and, right? Because if this could be for the in order of, I mean out of the in order of the array, or this could be any of condition could be for the out of in order of array, right? So let's again run it. Yes. So now we can see the smallest one is the 6 and the largest one is the 8, and the subarray sorted is nothing, and the index is the 5 and 7. This is what we got. I mean we calculated here, right? Now let's just okay. Now let's check the if everything is sorted. So what you can do, you can just say okay 5, 6, 7, then 8. Okay, let's run this again for the all sorted array, right? So if we run here, we again it is already sorted, and okay it's -1, right? And this if you'll see this is nothing but the largest, smallest is the largest integer, and the largest is the minimum integer value. So that's all about this sorted array algorithm. Okay, now if you see what is the complexity will be, there is I mean space complexity is nothing order of one, nothing with a constant, and the time complexity is order of n, right? Because here we are using the for loop only once, right? One this for loop, then the this for loop, and then this for loop. Three times we are using the for loop, but there is no nested for loop, right? So that's all about this subarray sorted. Thank you so much.